The question says the frame in this box here, it's a frame, is indicated in the diagram and is made up of 12 plastic rods that have a total length of p centimeters. Now folks, if you count it, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 12 rods together has a total length of p centimeters. Okay, so we can say the perimeter of the shape is p centimeters. Now they say the width of the box is half of its length. So the width is x, the length of the box is 2x. And then they tell us that the height of the box is h. So folks, I don't have to tell you, each one of these verticals are h units long. There's 2 of those x widths, 1, 2, 3, 4. And of the 2x lengths, there's 1, 2, 1 at the back there, 3 and 4. So together, that's your 12 sides. Now they want to know if the volume of this box is a maximum. They want us to determine the length of the box in terms of P. Okay, let's see. The volume is to be a maximum. Find the length of the box. So we're supposed to find what 2x is, and very important, in terms of P. Okay. And they were so kind to tell us how to find the volume of a regular prism, which is usually the base area multiplied by the height. So this here is the base area. Now the base is a rectangle multiplied by the height. There's your base, there's your height. Okay, let's see how we can use this information. First of all, there's 12 sides. The 12 sides add to a perimeter of p centimeters. So let's start adding. We've seen that there's 4 x's. We've also seen that there's 4 h's. We also saw that there's 4 of those 2x sides, and collectively they give us p centimeters in length. Now that deals with a perimeter. Now, why do I need to think about that? Well, if you look at the volume of this figure, the volume will be the base area multiplied by the height. The base is x times 2x, which is 2x squared times h. Now, folks, this is the volume in terms of h and x. So in other words, there's 2 unknowns in my volume equation. At school level, you cannot differentiate with respect to 2 unknowns. So you are going to now use your perimeter information and put it into the information for the volume before you start optimizing the volume like they said. It's a maximum volume. Okay, so let's do that and let's see what we get. Let's first just work with our perimeter. If I clean this up a bit, I get 4x plus 4h plus 8x, which is p. Those two clean up nicely. I add them together. 12x plus 4h is equal to p. And then let's see, I want h by itself. So 4h will be p minus 12x. And then h is definitely p minus 12x over 4. Now, folks, I'm going to label that equation 1 and this equation 2, so that I can indicate that I'm now going to put 1 into 2, into Roman 2 rather. Okay, and then I have the volume in terms of x only. And that is what I needed. I needed to rid myself of that second variable, which was h. And now I can answer the question quite easily. It actually now becomes quite an easy question. Let's have a look. The volume is that 2x squared multiplied by h, and h is p minus 12x, all of that divided by 4. Okay, so let's make some space here for ourselves. If I now distribute the 2 into the bracket, I get 2x squared p divided by 4. Now, folks, that will give me px squared divided by 2. 2 divided by 4 leaves a half in our answer. Now, 2 times the 12x gives me minus 24x cubed. That 24 is divided by the 4 to leave me with, let's write this as a half, px squared minus 6x cubed. That is the volume in terms of x. Phase 1 of our problem is done. Okay, we've got the expression for volume. Yes, it is in terms of p, but remember p is a constant here, folks. They told us the perimeter equals p. So they didn't say the perimeter is between p and something else. It is p, so p is treated as a constant here. Okay, now I go into phase 2. I now take the derivative, I let it equal 0, and my reason is to optimize my solution. Now remember, I'm looking for x in terms of p, for 2x in terms of p. So if I go here and I differentiate, I get p times x. Remember, the 2 comes down. 2 multiplied by a half is 1. Minus 6 times 3 is 18x squared, and that is equal to 0. And look at how beautifully this cleans up. If I remove the x as a common factor, I'm left with p minus 18x, which is 0. Now, under normal circumstances, I would have argued that x is 0 or p minus 18 is 0. There's 2 factors. But now if I go back up to my diagram, x represents the width over here. Hence, it can't be 0 because it will take this dimension away and that one. So I can very confidently ignore this. This is not applicable. It is a solution to the particular equation, but it doesn't apply to what we want to do. So what is 18x? 18x is equal to p, and therefore x will be p over 18. Now, folks, that is x, but they wanted the length. The length, they told us, was 2x, and that will be 2 times p over 18, and that gives us a beautiful p over 9.